So in this video, we are going to try to solve the two variable chi-square test using the graphing calculator and using the chi-square test function in the graphing calculator. So I'm going to modify these notes to match the problem that's in my stat lab. I obviously worked this out earlier, but I have to change it because the numbers have changed from the last time I looked at this problem. So I'm going to kind of erase these numbers. So bear with me just for a couple seconds. Oops. Okay, so in the upper left part of each of these cells, I'm going to put the observed frequencies, 51, 5, 40, and 38, 8, and 28, and 45, 8, and 64. Now what you want to do next is to create row totals and column totals. And adding up the top row, what do we got? We got 56, 96. Second row, we got, 46, 74. Third row, we got 53 plus 64 is 117. And if you add up those three numbers, you get 10, 17, 17. 28, so 287 for the grand total. Now let's add up these columns. 9, 14, carry the 1. 9 plus 4 is 13, so 134 for that column. That second column, we got 16 plus 5 is 21. Third column, 12, carry the 1, 132. And if you add up these three numbers, these column totals, they should also add up to that column total, or the grand total. So 287 is the grand total. Now to calculate the expected frequency for each of these cells, what you under the null hypothesis of independence, what you do is you take each row total times the column total. So for example, to get the expected for this first row, first column cell, well, you take the row total for that first row times the column total for the first column, and then you divide it by the grand total. So you take 96 times 134 divided by 287. Whatever that works out to be. Well, I'm going to show you in your graphing calculator how you could do this. Now, in the graphing calculator, to do this sort of problem, we use matrix. The matrix command. So in the graphing calculator, let's go down to the matrix menu. You have to hit second and this button right down here. Where you see the X to the -1 button, well, hit second and then that button, and that'll take you to the matrix menu. And then right arrow over to the edit menu. And then select matrix A by just hitting enter, and tell it that you want a 3 enter by 3 enter menu, a 3 by 3 matrix. And what you want to put in this matrix is going to be the observed values. So 51, 5, enter. And each time that you input a number, just hit enter. So 51, 5, 40, 38, 8, 28, 45, 8, and 64. So matrix A consists of the observed values. Now I'm going to hit quit. Go back into the matrix menu. edit, down arrow to matrix B, and enter. And we're from scratch. It's a brand new matrix. Make it a 3 by 3 matrix. And now we're going to input the expected values. Now, what are the expected values? Here's what you could do. You see how down here in the lower left it says, the 1,1 position is equal to 0 or whatever, right? Well, we're going to change that to be saying it's going to be equal to 96 times 134 divided by 286. Hold on here. So it was what? 96 times what?
134.
96 times 134 divided by 286. 286. Okay. All right, and then it'll give you that number. It'll calculate and store that value. And then what is the second column times the first row? Total? Well, hold on here. It's going to be what, 96 times 21 divided by 287? 96 times 21 divided by 287? 286? Is it 286? Well, 287. Yeah. Is the grand total 287? 287. Oh, okay. We need to fix that then. So you can left arrow to go back to the first one here. What was the first one? What was the column times the row?
96 times 134 divided by 287.
Okay. And then the second column, first row, what was that again?
96.
Say it again.
96 times 21.
96 times 21 divided by 287. Okay. All right. Third column, first row.
96 by 132.
So say it again, please.
96 by 132.
96 times 132 divided by 287. All right. Now, second row, first column.
74 times 134.
74 times 134 divided by 287. All right, second column, second row. 74 times 21
divided by 287.
Okay. Oops. 287. Got it. And then third column, second row. Anybody?
74 times 132.
74 times 132 divided by 287. All right, last row. Third row, first column.
So would that be 117 times 134 divided by 287?
Yeah, 134 times 9 times 117. 134 times 117 divided by 287. So 134 times 117 divided by 274. Oh, so all right. Sorry. What was it? 287? Yeah. Get these numbers all mixed up. Second column for third row.
21 times 117 divided by
287. All right. Finally, third row, third column.
117 times 132.
Hold on. 132 Okay, so there. So does everybody understand what we just did for this matrix here? We input the expected frequencies under the null hypothesis that the two variables are independent of each other. So matrix A was our observed, matrix B was our expected. So go ahead and quit. And now go into the statistic menu, over to test. And go ahead and up arrow so that you can come up from the bottom and go up to option C, which is chi-square test. And it's going to ask what matrix contains the observed values. It's matrix A. And if you need to change that, you go into the matrix menu and select the correct matrix. But down arrow, expected matrix is B, right? B contains the expected values. And then down arrow again, calculate, hit enter, and voila. You've got your chi-square, test statistic value, and your p-value. All right, I'm going to go ahead and unplug this. And then go back to the problem. And it's going to ask, first of all, what's the null hypothesis and the alternative? Well, the null hypothesis always is that the variables are independent. Okay? The test statistic, that's the chi-square value. We'll input the 8.137. And hopefully we did not make any mistakes in putting our numbers. And then finally the p-value, that's reported there, 0.0867. And there you go. And then the question is, what is the final conclusion here? Well, with this p-value, it's greater than 0.01. It tells us to use 0.01 as our alpha level. Well, our p-value is greater than that, so we failed to reject. And so therefore, there's insufficient evidence to warrant the rejection. So that means that the two variables are independent. So that the direction of the kick would be independent of the direction of the jump. So that means that there's not enough time for the goalkeeper to react to the kicker. And there we go. So that's how you could use your graphing calculator using matrix together with that chi-square test to complete this sort of two-variable problem using the chi-square test to test for independence of two qualitative/categorical variables. And with that, I will stop this video.